All right. Good morning to you all. Sorry for the late um, recording of this tutorial, and also happy Easter to you all. A little bit busy, that is why. So this is the last lab that we're supposed to have, and I said I'll record it and I'll share it with you guys. So it's quite complex. It's quite long, but I will do my possible best to finish within an hour. And once you are done with this lab work and the last assignment, then the rest will be for your project work. So kindly take note of that. So okay. So let me create a new notebook, and this one I'll name it. Okay, so it's not even a new notebook. We're supposed to continue from our previous notebook. So I'll pick one of them that I've been working so far. Maybe the last group that I met, which is week 3. Week 3. That was week 4 rather. Yeah. Week 4, week 4, week 4, week 4. Okay, week 4, maybe I can pick the top ups and use their notebook to complete it. All right. So it's loading. Let's wait for it to load. All right. So this is where we go to with the logistic regression, and we said we'll continue with the CNN. The CNN. So let me go all the way down there, and let's start from there. The CNN. All right, so here we're going to import our libraries, a lot of them, although we've done some import upwards, but I'm still going to import all the libraries once again. All right, so let me see if I can increase the fonts. I don't know if I increase it will be big. I think it will be too big, or because you'll be typing a lot, and some of them I'll zoom out and zoom in so that you see it okay properly. So bear with me. All right, so let's import our library. So first we import OS. We also import glob. Okay. We also import NumPy. We've already done that NumPy import, but I'm still doing it because matplot lib.pyplot aspirity. Then also from what p import image, and from copy we import our deep copy. That's the first. Then the second part will be the touch. So we import touch, then we import our touch dot optim, that's optimizers. Okay, then also we import touch dot neural as n neural network, then also we import touch dot nn dot functional as of f. Then from touch dot utils dot data, we import our data loader. So we'll be creating a data loader to load our data sets. Okay. Then we also have our random split. Then from touch touch vision rather dot data set, we import image folder. Now this is a quicker way out for us to be able to load our data quickly. So I'll be using that because it's not physical. All right, so I want to use some ways to get things done quickly. Okay. And also talk about transforms. And from TQDM. Would I even use this? Will I even use this? Will I even use? I don't think I'll use this. I'll not use this anyway. So let me take that one out. Then maybe let me. So let me. Don't even attempt to use. I don't want warnings to show. So let me do that. Okay, one is then ignore. Then in order for me to know that everything is working, I can use what libraries. Libraries imported successfully. Oh. All right, so let's run our script. Boom. So session will start. And if everything goes on successfully, you are going to see the libraries imported. Okay. All right, so that is that. Everything is working. The first thing or the next thing is for us to get our data. Okay, so get the data. So get the data set. Okay, and also the directory. Okay. So this time we're going to deal with visual images. Okay, all this while we've been dealing with all numeric, but this time we're going to deal with visual images. So what are the what data set are we going to use? So it's public. You make it we'll go and look for that data set. So we click here, then we go to add input, then we go to data set, then we type the name, which is brain humor MRI data set. Is done by this guy Masood, this guy, because we look for the name brain tumor MRI data set, Masood, whatever. So you can read more about the data set, or you just add it straight away to your directory. Okay, so I'll just click on this to add. Once it's added, you will go in, be able to see more about it. So here, you see now I have two data sets. You have the logistic and also have what? The brain tumor. So let's click on this. You see it has two directories, the testing and the training. Let's go into the training, and you see that it has 4 subdirectories: glioma, meningioma, new tumor, and pituitary. So here, you are going to build a simple classifier that, given an image, it should be able to tell you that, okay, this is a glioma, this is meningioma, this is a new tumor, this is a pituitary. So this is a classification thing that we are going to do. Now let's look at the total number of data sets. So here is 1,400, 1,400, but thank God the data set is actually balanced. Okay, because I think they are all the same. Okay, hardly will you get this in real life. Hardly will you get a balanced data set, but I think this is balanced for us. The person curated it well. Then the testing also is also here, the same data set. Okay, so our task is to build a simple model and use CNN, convolutional neural network, build it from the scratch and use it to do a prediction. Now, it will be open. Okay, some of you, you can improve upon whatever I'll do add some plots, all those things. Okay, so the more things you add, the more marks or score that you will get. All right, so I'm not going to build everything, but I'll build a lot of things, and I'll leave the rest for you to complete. Then I'll send you guys your lab work. The lab work too will be similar to this, which I'll just give you a data set and ask you to build a simple classifier from it. So you can use your previous code that you have written. All right, so let's get our directory. So the first thing you have to do is to get our directory. So we set train directory, then we copy, so which is this part. You need this whole part, so I can copy this part, which is for my train directory. I paste it over here. Have you seen it? So train, then I copy the part, paste it. The next thing is to get my test directory, which I want to also copy this one. I can close this so that I can see the view. Then, oh sorry, and I want to paste it. So I also have my testing directory. So I have two directories now. Now remember, is the directory, but not the images. I don't need to get confused. Okay, we say the directory, it's on the path to the data, the path to the images, but not the images. So if I try to print any of them, it's not going to print the images for me, just going to print the path. Okay, so what we have to do now is to be able to get the individual files. Get the individual file. This is where it's a little bit challenging at first, but the code is here. You can watch it and try to get the individual part. Okay, so let's get a walkthrough of our data set and be able to load all our all the files into a list, so that with that be able to have access to it. So we can use data frame, but I mean, data frame, we have to create a dictionary, all sort of things. So the list is far much simpler, although the list is, it takes a lot of time because it keeps appending, that is a lot of time that it takes. So, but we are still going to use the list. Okay. So let's have a walkthrough of our data set. So a walkthrough of the data set. All right. So let's have a walkthrough of the data set and see our data, because they are visuals. How will you know they are visuals? So we create a function over here. So a function, okay, to load all the files into a list so that we can get access to it. So the name of the function is data walk through. Okay, then I pass what my data directory to it. So here I'm passing my data directory. That means, and I create a list over here. We create a list over here, which is then I also have what data label auto list, which is this. So here there are two things. Remember, okay, the images you saw over here, okay, here, these are all files. Okay, if I open it, it's going to expand the whole space. I don't want to do that. So here, these are images. Okay, each image has a label. Okay, a label is what I use to identify. So when you see the image, what is the label? So here, if you look at it, here is a TE, then glioma, whatever. So the same thing with the meningioma. If you go here, you see that it shows you meningioma. Then if you go to no tumor, you know, then what again? Go to our pituitary. So the labels have been assigned to the files. Okay, so here that is why we need this. We need this one to tell us. So this is actually the files, which is the image itself, and this is the label. Okay, this is the label. So it's like you taking a picture. If I see the picture, okay, I might know you, but if there's a label attached to it, that this is maybe Seth, or this is Fred, or this is Otis, then I'll be able to know, right? So that's the same thing I want to do. So we have this empty list to be able to populate it and get all the data. So let's have a walkthrough. So to do that, we use a path, which is directory path. Then we also get the directories, we also get the files. Okay, in os.org we work. Okay, this is a working we are doing. So we work with the directories. Then with that, so for the files, name in glob. This function is very, very important because it's going to help us to be able to get all the files, because each file has an extension. Okay, so if you look at it, I'm saying that star.jpg. What I'm saying is that go into the folder or go into a directory, then the directory have subdirectories. Go into each subdirectory, the files. Okay, so when you go into the files, check the files, each one with the extension .jpg, add it. Okay, so we are going to add it, append it. That is what we are doing. So we are using this to be able to read. That is the function of the glob. It's going to read all files that has these extensions I'm going to specify over here. Right. Now I don't want to specify one extension because sometimes your images, you think they are all JPEG or JPG, but it's not true. Okay. So to be at the safer side, why don't I use all the image extension which we use? Okay. So the other one too is what .png. All right, then the last one is the JPEG itself. Remember the JPEG, we have two. We have the JPG, we also have the JPEG. They are not the same. Okay. All right, so can we take note of that? So we have this, then which is this, then our JPG. This is fine. Then make sure you don't forget your colon. Then I can come down. Then now do my append. So the list is our append. Then file name, then we have our data dot list, so a label rather, or list, append, or file name, then split, then here we split and get the thing. I wish I could do some of these things, but so here, if you look at our data, because when you read this, you see, this is the full directory we are reading. Okay, so if you look at the 4 slashes, that is what we are expressing over here. So we are saying that, okay, we are saying that, even let me show you something like that. So let's pick any of the images. Let's copy the path. So let me copy this one, put that one here to show you. I'll clean it later on. I can leave it over there. All right, so look at this. Okay, so let's look at this. So look at the path. It goes all the way to this place, right? So what is the extension? The extension is with JPG. So I'm saying that, okay, go into the directory. When you go into the directory, you see some subfolders. That's why you see the directory over here. So this is the path. The path goes all the way to the testing. So then you see some subdirectories, glioma, then the files. Okay, so the files, we are going to use the glob to read, and we are using the glob to check. You see the extension over here, the JPG. So here that means this is going to catch it. Now once you've gotten it, remember it's reading this full path. Oh, you're not reading only this. Okay, it's going to take the whole path, okay, to the image. So here what do? We append, which is the file name. So this whole thing will be appended, but I only need the label. The label is only I think this is what I'm, no, the label is the glioma. This is what I'm looking for, not this. This is what I'm looking for. This is the label, okay, because all gliomas have been put in a directory. So this is what I'm looking for. So this is what I've done over here. So remember, this one will contain everything, okay, which is the path to the image. But I want the label. So the label is where we split. So we are going to split this full part into a list, which they to be done using this. So we are going to have cargo, input, whatever. But I need the second, which is when I start counting from when I start counting from the right, I need the second thing. So it's going to be -1, -2. So it's going to return the glioma. It's going to return the glioma and append it to our list. It's going to return the glioma and append it to our list. So that is what is going to happen. All right. So if you get it, that is so. When I run my script, when I run this script, which I have to return first, because I will need it later on. So let me return. Okay. Now it will not be safe if I want to print. I mean, return will be very, very important because I will lose it in other words. Okay. So I'll just return. If nothing goes wrong, then boom. Now let's have a feel of some of these things. Some of these things you just have to have a feel of it. Okay, so let's just go through, like if we're supposed to use data list, then label list. Okay, then we call the data walkthrough. walkthrough. Then we have our train directory like this. Okay, so here we have access. So it's going to take some time because the data is quite a lot. Okay, so here let's just have a view of some of the data. So just I'm just doing for the train. I could also do it for the test too as well. So just a view, okay, of the data. Now if I say a view, it's not going to give you visuals. Okay, it's not going to give you visuals, but rather it's going to just print the list, okay, or the path, and also the label list. So let's have one of them, which is data, which is list. I just want only the 5 of them. So let's see here, and now you see this is the label list. So it's creating it all the way to that, as I said. We can also do one also for the label, which I can also have on data, or label list. Okay, label list, then and 5 like this. And let's see that one. See picture. As you can see over here, I've seen PI. So that is that. So we now have all our data in a list form, right? In a list form. All right. So let's see the structure of our data. Okay, so we can be able to find out, okay, some information of our data. All right, so the first thing is let's view the dimension of our data, and even what again can we even view? The mode. Okay, we'll view the dimension because we don't know the size of our image. Okay, the dimension of the site. The dimension or size. Okay, and also view the dimension of the size and also the mode. Okay, of asset. Now remember the mode. Is it RGB? Is it grayscale? We'll find out. So we use the image, which I pass my data list. I pick one of it. Okay, I don't need it. Then I apply the size to it. I also have the same thing, image dot open and data list. Then I also pick the same item and I want to find the mode. So let's run it. So here it's telling me that the size is what? Is or the resolution is 512 by 512. Then it's of what? RGB, which is red, green. That means it has 3 channels. 3 channels. So remember, 3 channels is quite a lot of data that you're going to do with. That's quite a lot of data you're going to do with. Okay. All right. So now let's try to plot. Now you've seen this, that everything is working fine. The next thing is we have to plot. So we need to find a way to plot. Okay, so let's plot. We need to observe some of these things. Okay, so plot through. So let's plot. We'll plot some of them. We'll plot the training and also the testing. Okay, so plot through. Okay, a series of what? Of training and testing sets. All right. We have def plot, then images, the data we pass the sentiment, the data label, sorry, list. All right. So n number of rows, number of columns. It's like, I don't know if you guys have done a little bit of MATLAB, so you understand subplot. So I'm doing something like a subplot. Okay, I'm doing something like a subplot. PLC dot subplot. This is subplot. Subplot is on n rows and n columns and fake size, which I'm setting the size 16 by 12. All right. For IDX in range 6. Okay. All right. So we pick the image path. Then we are doing a random. Okay. One thing is that we don't want to print all of them. Okay. So we do a random. So we use a random choice. So each time it's going to return a random image for us. Okay. Now this is fine. Okay. You guys say this is fine. We don't want to be printing the same kind of image anytime you run that cell. Okay. So you just want to IDX. We just want to print different. Okay. All right. So show the np.array. Then we convert. Now, one thing is that because we are using the matplotlib, you need to convert the image actually to array, okay, so that the matplotlib can handle that. Okay, I could have used other libraries in Touch, but I don't want to stress you guys because some of you are not learning. Okay, if I make things complicated, some of you get lost along the way, you give up. So this is fine. Okay, as a beginner level, this is fine. All right. So here, that is quite a lot of coding I'm doing now. I know some of you will give up, but please don't give up. Okay, this is the last thing left. All right. Then we also have another one, which is this dots, then flats, IDX, others. Then I don't put any others over there. So if everything will go on well, then I can go ahead to tighten my layout. Then pt plt.show. All right, so let's see. Okay, now this is a function. So sometimes you can plot a function. Sorry, you can write a function and you think that there's nothing wrong with it. Yes, unless you call the function. But you call the function and you realize that you have a lot of errors. So here it didn't give me any error. But let's see, when I call it, will you be able to do whatever I want you to do? So here I visualize my set. All right, so let's visualize some of the training sets. Okay, so visualize some of the training sets, All right, so data or list and label list dot also list is equal to. So here you call our walkthrough. You know our walkthrough already, which is a training directory. Then here you plot images, the data list, and label what list. We have this now. All right, so let's see. Nothing goes wrong. Boom. Nothing goes wrong. It will take some time. Okay, depending on your internet connection. Okay, so here say a plot image is not defined. Plot images. There is a plot image or plot image. Yes, you see the mistake I'm doing. So let me go back, change it. All right, so as I said, depending on your internet connection. All right, so n row is not defined. What mistake am I doing though? Okay, so we'll add S over here. All right. So I'll go back here, and pray we don't get any error. Okay, boom. So here, these are our images. Have you seen it? Nicely done. So glioma, this one telling that this image is glioma, this is pituitary. This is pituitary. Meningioma, glioma, glioma. So this is just a random plot. So I'm lazy, so I just have to copy this and do the same thing also for the testing. So copy this, put it over here, then we change this one to testing set. Okay, so testing set. So what I have to do is to change this one to test directory. All right, then I think that'll be all the same thing. All right, so to just go and plot the testing also for us. All right, so as you can see, this is the testing one. But if you look at it, you see the images, they are not of equal size. Okay, for example, look at the testing like this. Some of them bigger than others, and yeah, some of them yes span. So this is where we are going to talk about data preparation. You need to prepare your data before you feed it into your model. Okay, you remember we saw the size to be what 512. 512 is quite a lot. 512 is quite a lot. If you should do the math, you remember you are going to the resolution is going to be which is 512 times 512 again. Sorry, 512 times 3. Okay, because you have 3 channels over there. So this is what you have. Now, how many images do we have? Okay, if you check it, we have a lot of images. So let's assume we have 1,000 images, right? 1,000 images. This is the number of pixels that's going to go into. That's quite a lot. You think that is nothing, but that's quite a lot of data. All right, so we need to shrink this size a little bit down so that we can feed it into our model, and our model will be able to train it within a limited time for us. Okay, we can't be training it forever. So we're going to talk about data preprocessing and normalization. You remember when we were dealing with the logistic, I made mention of what standardization or normalization. I think they are different, but now it has become the same. Okay, so where people normally call data standardization and also normalization the same. Okay, so let's try to prepare our data and also normalize it. Okay, now one of the things the last time I did explain was deep learning model, as I said, they pay attention to what values or higher values. Why do they do that? I don't know. Okay. And even in life, why? I mean, if somebody scored 99% and you are scoring 40, the person who had 99 will pay attention to that person, right? Because we think the higher values are significant, which maybe might not always be true. All right. So what do we have to do? I think I have to change this. Data pre-processing, not processing. Okay, we need to pre-process it. So pre-processing. All right. What we have to do? So what we are supposed to do is try to figure a way out how to put all the pixels in the same range. That is normalization. You have to put all the pixels in the same range so that it will be fair to all the images. Then you also have to create something known as data loader. Okay, now if you are feeding your images into your model, you have to feed it in such a way that you can't feed it one by one. We need to find a way, I don't know, a practical analogy to explain to you guys, all right, where, yes, it's like maybe somebody is going to marry someone, okay, and you can't just bash into the house. No, we need to prepare, come with your family, everything before formal introduction. That the same thing over here. All right, you can't just put your data straight away. No, you need to, I mean, put it in a way so that you can feed it into your model. Your model will be able to understand. Okay. So the first thing we are going to do is to do some stuff, which is quite a lot, but I'll try my possible to code all of them. Okay, so you're going to have something as compose. Okay, now in composing, what you do is that you take your images and try to convert them to touch data type, okay, which is tensor, so that the model will be able to work on. Remember last time when we were explaining, I showed you the device. You even talk about the devices. One is where I said you move your thing to a device before you do that. Was it here? or the other tutorial rather. Okay, well, if you don't move it to a device, okay, it will be a problem. So we need to be able to do that. So we need to do the same thing also for our images. So let's create a temporary one. Now the temporary one is just to help us be able to do some calculations, but we'll have the original one, okay, for our data. So we need a temporary one to be able to do things like normalization. Okay, so here we have to image, which try to convert it to touch for us. Then we also have to resize, okay, which we specify the size, which is a 224. And anti-alias. Okay, if you know anti-alias, sometimes when you zoom an image, okay, you see you say it pixelates. Okay, it pixelates. I don't know, you guys will do that when you are into that. Okay, so you understand that. Then touch dot float 32. So here, what are we doing here? So here we convert the image. Okay, we resize it, then we convert the touch actually to float 32. Don't use it for this. Is quite a lot, so it's like rescaling. Okay, it's like rescaling. Right, it's like rescaling. So we can do that. So here rescaling. So scaling, it is what, one, I think 10 rather. Okay, let me zoom out small. Okay, it's fine. All right, so rescaling this. All right. So now that we have this, now the next thing is, let's try to load our data set, a temporary one. Okay, we need a temporary one to do that. So let's run this. Okay, so you see, got an expected anti-alias. That's how I'm spelling it. Added E to it, forgive me. All right, so now let's load the data set from the training set and use it to do certain things over here. All right, so load the data set from the training, okay, folder. So here we use the train, okay, data set. Then here we use the image folder. This is very, very efficient. Okay, I wanted us to build a data loader, but because this is online, it is going to worry us. So I think we can stick to this, which this is fine. And it tells the composer. So you see the composer over here. I'm passing it to this. So when I'm saying that you load, it's going to load a train. Okay, then get the files, then apply everything we said over here to each file over there. All right, so that is the loader. So we have our temp loader, which is our data loader here, and we pass our train data set to it, and we set the batch size. Now batch size is equal to 32. What is the batch size? The batch size is like you grouping your data set into chunks. Okay, you group it into chunks. It's like me grouping you guys, putting you guys into groups. So this is group 1, group 2, group 3, group 4. So in a class of 100, I can have a batch size of, let's say, 5. If I have a batch size of 5, then 100 divided by 5. So I'm going to have 20, 20, 20. You understand? If I have a batch size of, let's say, 50, okay, no, 50 is quite a lot. Okay, if I have a batch size of 50, it means it's going to be what, 100 divided by what, 50, which is going to be 2 groups, 2 groups, 2 groups. So 2 groups, how many? 50 times. Okay, so when you say a batch size of 32, it means that I'm going to take my training set divided by 32. When I divide by 32, I'll get that groups. So it's going to be a group of 32. Okay, so for each POC, I will pass. Okay, I'm going to pass all these groups. Okay, and I'll be doing updating. Okay, there are a lot of things that goes over there. Sometimes you can do stochastic gradient update, or you can do there are different updates that you can do. But so we set it to 32, but most of the time is I think powers of 2. Not that thing, it's powers of 2. So we see people setting to 4, then 16 to 32, then 64. But 32 has been seen to be the one that gives us better results. So let's stick to that. All right, so the loading is going to take some time. All right, so let's go on and do that. Okay. All right, so what do we need again? Okay, so we need to, I need to do some calculations somewhere, but I'm coming. I need a whole file. It's quite a lot. It's quite a lot. I wish I'd be able to do that quickly now, but okay, let's go. It doesn't matter. So let's do the calculation. So remember, we said that the image is RGB, right? RGB, that means 3 channels. Okay, so this is 3 channels. It means we are going to have 3 different values. So one for the red, one for the green, one for the blue. So even if you want to normalize it and do calculation, you need to do calculation for each channel. You can't just do calculation for a single channel. So you have a function called statistics channel, right? Which is what? Images, then what? Labels. Okay, so here we pass the images, we pass the labels. Okay. So one thing that we should have actually shown you was to know how our data sets actually, arrange. Okay. And the way I can do that, I think I could have done it over here to show the dimension, but I don't know whether this guy has a dimension to it. Dimension. I'm coming. Let me verify whether image has a dimension. No, I think it doesn't have. All right. So in touch, okay, the image are actually put like this. Right? So we have the number of images you pass the n, then the C is the channel, the H is the height, and the W is only the weight. Okay. So we put it in that order. The number of samples, number of channels, number of height, then number of weight. We pass that to then have our images or dot size. Here is it. Okay. Then we have to flatten. Okay. The weight. Remember flattening? So you flatten it. That means all of them become out. So flatten the channel, which our images dot what reshape. Then we have what more samples. What n channels. Sorry. N channels. Then what negative 1. We have this. All right. The next thing is you're going to do some computation. So you compute statistics of each image per channel. So we average the pixel values channel, and then lastly, which is n sample, all right, our n channel. This is like some mathematics we are trying to do. Okay, so we want to be able to find the average channel, which is mean, then others, then 2. Okay. So what do we have here again? So we've done that. The next one, we add up statistics of all images, in a mini batch. Sorry. Then, which will return one the not n channel. It's quite a lot of typing. You guys will be in trouble. We sum the means. It means dot what sum. Then others 0. And what do you have? Sum. Standard dot what sum. Then others is the one also to 0. And here we mix our a tensor of shape 1 n channels and with the number of what samples in the mini batch. All right. Any sample is equal to touch dot what? Answer, which we come here, we'll do some kind of multiplication. Channels, good. Okay. So here we stack everything and we return our thing back again. So we stack. So we stack the 3 tensors on top of one another, which is our 3 n channels. And here we return touch dot stack, which we have this, which is equal to n samples, and sum means sum then what? Standard deviation. Then what we have is 0. All right. So let's run it. Okay, as I said, sometimes when you have a function, you will not see that you've done a mistake till you call the function. So now I've run a function, but I'll call it later on. Let's create another function called loader. Okay, apply to be able to load our data set and apply the function to it quickly. Okay. All right. So here we have our results. So we create a variable called results. Then we have func x, y, and what I, then what x, y. Okay, enumerate. We have what our loader. All right. We have our results. Go to touch dot what stack again. Results, then what others is equal to 0. And here, if reduce, is equal to sum, then we have our results is equal to result dot sum, then what others equal to 0. If reduce is equal to mean, then what do we have? Result is equal to result dot what? Root dot mean, then what average equal to 0. All right. Then we can return what? Results. So as I said, it's a function. So some of these things you will never see till you call it. So let's normalize. So we have another function called normalizer, which is named called normalizer, because we need that one to be able to normalize our image. Okay. Now the reason we are doing this is because when you check on the internet, they normally put some values over there. Okay. And the value they put over there, it is people's work. Okay, they came out with that and they came out with that value, but we are dealing with a different data set, so we can't use that. That one will not be correct, although other people use it, it's fine. But we want to get our own values from our data, and that is why we are going through all this stress to do that. Okay, so statistics per channel. So here we are calling the function now. So let's hope that nothing goes wrong. Okay, so norm and mean, because a lot of typing, then means is your total, then you have what? Samples, then norm dot what? Standard deviation, which is what? LDS, total dot what? Sample. And here you return. We're going to come down and return v2 dot what? Normalize mean is equal to what? Norm dot what? Mean standard deviation dot what? Norm dot what? Standard deviation again. So let's see. I pray nothing goes wrong. Because okay, and that's it. So let's make our normalizer now. So we are getting a normalizer from our images. Remember, we created a temporary composer. That is what we are using to do that. Okay, so we use the temp. Okay, do that now. Then we should be able to get our normalizer with the values. So it's supposed to return 3 values each for each channel. Okay, mean is not defined. Which is that? Mean is not defined. Where from this? Where is the line? Mean is not going to define. Oh, sorry. Where is the mean? It means not means. Which line is that? I'm lost. This is where the bargain is very, very crazy. Line 16 statistics per channel. Line 16, yeah. But how will I make it? Okay, but how? This is mean. Where from my standard deviation? What are I going to do? You're supposed to means rather. Then when I get the means, here's the standard deviation. I'm supposed to calculate something somewhere also, which I didn't do it. Wow. Let's add. So, okay, I'm supposed to calculate the standard deviation, that one also. Okay. Which, yes, which is standard deviation like this. So, standard deviation of what? Of the values per channel. What is what? And samples. No, and channel. Right. ADS is equal to flatten the channel. ABS there as is 2. Yes. So as I told you, sometimes when you come up with a function, you never know the function is working correctly until you call it to do calculations for you. Then you see that the function would hit you right on the head. So let's pray this one works perfectly. If it works, supposed to return 3 values. Okay. 2 groups, but 3 individual values. All right. Yeah. Okay, so let's wait for it. Let's wait for it. Let's wait for it. It will take some time. With some of these things, please, if your network, misbehave, you will always be in trouble because it takes some time to load some of these things. To run some of these scripts because you're doing calculation from all the data sets that we have. So let's wait for it to respond. To complete. Once it's done, we move on. All right, so it's done now, as you can see. It's done, as you can see. So here the normalize the mean 1, 2, 3 by standard deviation. So this is what we are going to use to normalize our data set. So once we have this, thank God. But as I said, when you go into literature, there are values that they use. Okay, there are values that they use, but you want to calculate one. Okay, so let's now apply the actual composer to our data set. So now that we have the normalizer, we can now apply the actual composer to our data set now. So let's apply the actual composer to our data set now. So here we have the original composer now. So the first one that we did was just to help us get the normalizer. Okay, that's why we make it temp, right? And this one we are done. So we still resize again. All right, so now we resize to 224, which remember the size was what? The size was 512, right? Now we are saying that bring the 512, bring it down to 224. Then also apply center crop. So we crop it from the center so that we won't lose a lot of data. Okay. Then also convert it to PyTorch image. Okay. Then we also scale it using the TouchFlow 32. Okay. So then the last thing is what we apply. We can even do some form of augmentation where we do random flip and all these things. We can do that. Okay. Sometimes you want to do random flip so that your model will be able to understand some of these things. But it's up to you. Okay, you can do that yourself. So here, the normalizer. So this is the normalizer that we are bringing. Okay, in actual sense, you're supposed to put a value over there, but we have done a calculation. That is why we are putting this one here. All right. So now that we have this, we are good to go. All right. So module Vision Composer. It's compose. I'm creating my own script. Sorry, it's compose rather, not composer. Okay, so now that is done, we can now load our data set from the training folder. So let's load our data set. So we are still under data preparation and all this. So we load our data set, then we can split it. All right, so load the data set. So let's load. So we have train data set underscore data set. Then we have our image folder. Okay, then we have the root, which is the train directory. Then we see the transform. So here, they're saying go and load it. So each one apply the transformation we have specified over here. We use composer to it. So bam, it's going to take some time because the data is a lot. So the next thing, whilst it's loading, we can go on to split our image. Remember, we are still splitting the set over here, but this time we're going to split it into we already have our training set, which is over here, right? But the testing set, we're not going to touch it. But we're going to split the training set into validation and the testing. The training set into validation and training. And why do you have to validate? I've said this. It helps you to fine tune and also check if your model is not overfitting whilst you are training. Because there are two things last time. Either your model underfit or overfit. So once we are training, you can check all those things. Now, I wish I could take you guys through a full course on this, but we don't have time. So I'll just go straight and split it and just load my things and go. Okay, there are a lot of things that I could have maybe show you or expose you guys to, but our time is not on our side. So let's split it. So here we define split size, okay, which is 80%, sorry, 80% for training, then 20% for validation. We do that. All right. So here we have train and what size is equal to int, then 0.8 dot length, then we have what train what data set. We also have what valid size. But the valid size we see over there, that is the validation side, okay, which we also have the length, and we have our train. So here, just simple mathematics we are doing over here. All right, then we minus it by the train set or the train size. Okay. So now that we are done, we can now go ahead, boom, and do our splitting. So here we have training DS, which is training data set, then valid DS, then with the random split, which is train dot data set, then we have train size, valid size. We have this now. Okay, so we split the data set, then bam, nothing works. Then we do the same thing also for the test. Okay, we do the same thing also for the test. So let's do one for the test. Okay, so let's load it from the test. So as we did over here, so load the training data set. So here must be what? Load the training data set. So let's copy this, bring this one here. Then here's supposed to be the test then. Okay. All right. So we change this one, as you know, we just change this one to test, right? And we apply the same thing to it. Okay. Apply the same thing to it. So we've done that. Oh, I'm going to change this one to test. Sorry, forgive me. Oh, that's my window. I'm making a mistake. Oh. Okay. I'm going to change this one to test DS. Okay, so test DS. So I'm going to run again from the top so that doesn't cause any conflict. So here comes, and here comes because I need to get the train set correctly. Then okay, done. I split. I do this. And this is my training. These are my testing. All right. So I have that one also. Okay. Now that I have this, let's create data loaders for batching. Okay. So this is where I did explain the batching. Okay. So create data loaders for batching. We have what train loader, which is equal to data loader train ds, then what batch size 32, shuffle true. We have our train, which is valid rather. So we are valid at loader, which is equal to what? Data loader valid ds, then batch size 32, then we have shuffle, then our false. So we have what test loader, which is equal to what? Data loader test ds, batch size 32, shuffle, and false. Now we don't shuffle the test loader. You don't shuffle it, okay? You also don't shuffle the validation, okay? Because that's what you're using to test them out. But you only shuffle the train. That's why you see here the shuffle set to true. Then the batch size, I did explain to you that, for example, if I have a student and I say I want the batch size to be, let's say, 5, I should divide, if the student they are 100, I divide 100 by 5, I have 20. So the batch size is going to be 5, but the number of individuals will be 20 5 times, okay? So let's routing, so let's bump. You see test ds is not defined. All right, so I made a mistake here. It's supposed to be test ds, not test on this. So go back, run this one again, and run this one again. All right, so now you can go ahead to print and see, okay, what we have. So if you do the calculation yourself, you're able to show here. Let's print. We'll print our data set. Yes, we just print. Then I have what? I use the F print. Your training samples, which I use my length. Train what? Yes. Okay. Yeah, print, which is a validation samples, which is length, which is valid ds. Okay. I think I don't want to make a mistake. No, there should be something here. There should be another parenthesis over here. Or it's not work. Then we can copy it without changing it. I don't need to type everything again. All right. So here is the testing one. Testing sample, and then this will tell the all right, so boom, let's see. Okay, so everything is intact. So here telling that this is the amount of images I'm using to train. This is the amount of validation. This is the amount of our testing. All right, so let's try to have a feed of our data. Okay, so let's have a feed of our data now. So we are still under data. So there's something called data exploration. So let's try to explore all the things that we have done so far if our data is actually intact. So data exploration. Okay. So here, what do we have? Let's iterate through our loaders. So which is this, the y-axis is equal to next. Then we iterate through any of them. Yeah, you can use the test. We are using the valid. Okay. We just want to see stuff whether our things are actually going on well. Yeah. So here, x does shape, then y-x dot another shape again. Then width, then what? Height, or shape 3 dot sorry comma x dot what shape or 2. Sorry, it might be 2. Oh, 2. And here we print. We do mj for the width and you know what height. All right, so let's see. Let's run our thing. Okay, so here tell you that what got the bus size, the channel, and the size. So it tells you. Okay, so here it's saying that the x, which is the features, these are the features, and it's my target, which is trying to tell you, okay, I'm coming. And that's the y shape. Are you making a mistake again? I think that's fine. That's fine. Okay. So everything is working now. So let's try to view a batch. So we want to see the batch. Okay, so if you have your calculator, if you do it, we're able to see, okay, so view the batch size. Okay, all the data point. Which is what? Len, iteration, the train loader, then I've learned a activate, which is what? The value loader. Okay. So bam. So here you're going to see this. If you do the calculation yourself, you're able to know because we saw this to be this. So if you should do it, let's divide the 4430 by what 32, and we're supposed to return 140. As you can see, you can also do this one also for the other one too. Is 1120 divided by 32, supposed to return 35, as you can see. So here it means these are the chunks of groups that we have. Okay, so we have what 140 groups. Okay, 140 groups. I don't know if that is correct. No, we have but when you say a batch size of 100, so if I say a batch size of, let's say 5, I have 100 students, and each group I'm going to be 100 divided by 5. All right, so each group is going to be 20, 20, 20, 20, 20. Okay, so this is I'm going to have 32 groups. Each group for the training set is going to be 140 images, and for the validation also I'm going to have 32 groups, and each group I'm going to have 35 images. That is what we have over here. Okay, so let's again keep exploring our data to see what we are up to. So what we can do is let's try to print. So we print the train. Remember initially I show you the directories, okay, and a class to IDX for us. So here, if you come here, you see Sebo is clever enough to tell us. So here, just doing some encoding for us. So glioma is 0, as you can see, position 1. The meningioma, position 2. New tumor, like that. Okay, so this is very, very important so that we don't need to write a full script to do that for us. Okay, because of the image folder was able to handle this for us. We just pass the directory, we pass the composer. And you need to have your data set arranged in this order. Okay, you need to put them nicely and be able to do that for you. Okay, all right. So here we can view any of them. So let's try to view any of them to see. So here we have MJ and label, then we have our train. Yes, so here we just want to view maybe the 5th image. Okay, so the 5th image. So we have show here image and permute. All right, so 1, 2, 0. Because we are passing the thing to Matplotlib, we need to rearrange the image well, or it will not work. That's why I'm doing the permutation over there. Okay, so add this, then off. I don't need any of this. Then show. Okay, so let's see. All right, so Boolean, ambiguous, what am I doing? Permute, I'm not permuting anything. Where? What am I doing? Whoa. Come again. Oh, sorry. I'm sure, like this. Okay, all right, so we have this over here. So this one It's able to drag one for us, and we realize that one is a meningioma. So you see, this data has been pre-processed nicely. Okay, and pre-processed nicely. We can also do one also for the valid. So we can do this, copy it, paste it, bring it over here, change this one to valid yes. Okay, valid yes, and boom, we are gone. We don't have any issue. Okay, so that one, you see, nice. It has pre-processed the thing nicely. You can also do the last one also for the train. Just want to make sure our things are working on well. Sorry, the test, not the train. All right, so that one to boom, let's see. So each one, so this one is meningioma. This one too is, sorry, this is glioma. But if you check the thing, glioma, then 3 is what? 3 is pituitary, and 2 is no tumor. So in our image, we pre-process it nicely. All right. So the next thing is for us to build our model, which we're going to do a lot of coding, which are not being done anywhere. Okay. All right. So build a model. Now, since you are not doing transfer learning, you are not doing a lot of stuff, I just want to stick to something. This one. So what I need is I need to specify my filters. Okay, so remember the filters, they are also known as the kernels. Okay, so you can decide the number of filters you want to use. But most of the time, they are all numbers. You remember last time I said, okay, and they are all numbers. And also the size is also what? All numbers. Okay, so here I want to specify filters of 5. Then we want to prevent overfitting. So there's something known as dropout. Okay, dropout, the probability. All right, so I will set a value also for that, because you don't want to have data to memorize the training set so that you're able to perform well. All right, so you are going to use the dropout probability to control that. All right, so let's start. Quite a lot of coding for us to do, so let's start. But the training is what is going to take a lot of time, because we have more coding to do. Okay, I wish we were to train it. Okay, so I wish I could find a better way how to train this model. All right, so let's start with our model. So here we create a model and send it once to the device. So we send it once to the device. Okay, I don't know. I think I've explained the device to you guys. Okay. Okay, so we have a number of filters that I want to specify, 5. Then the probability is 30%. That means dropout. So what is dropout? We're going to find out. All these things is better for us to find out, so that all right, so dropout. So why do we need dropout? So dropout in ML, all right, or deep learning, dropout. All right, so dropout is a regularization technique used in deep learning to prevent overfitting by randomly deactivating a fraction of the neurons during training. This forces the network to learn more robust and generalized features, improving the performance. So some of the neurons, they are not supposed to actually learn anything. Okay, so we deactivate them. And there's a probability we use to do that. Okay, so when it falls below a certain probability, we can deactivate some of them. That, hey, you've learned enough, don't learn again. Okay, so here we set our model, which is a sequential, that we are going to build in a sequential way. All right, so the first thing is we have our featureizer. I mean, we're going to learn our features using what the CNN, which is the convolutional neural network. Okay, so we have block 1, which we have this 224, sorry, by 224. All right, then we go number of filters. So here it's going to return the number of filters for us. Then at 224, then 224. Okay, then this will return the number of filters again, which is what? Now we'll be doing mass pooling. I think I've explained the mass pooling to you guys. You can go and check your slides. All right, so model dots, we add a module to it. Then we use the conv. So here, the conv1 is just a name we are giving to it. Okay, We're using convolutional 2D. 2D means we're expecting what? A data of what? In the form of a matrix. Okay, 3 and out, channel, and what? Filters, then what? Kernel size is equal to what? 3. Okay. So is that all? Can we add more stuff to it? Let's see if you can add more stuff to it. So kernel size equal to 3. Then what do we need again? We need the padding. All these things I've explained them. So can you go and check your notes? Okay. All right. So we have this now. Once you have this, you can now go on then to add our nonlinearity to it. So module here. Then we have the value 1. Okay. We need the value. Okay. Then we have our model dot add a module, the max pooling 1, and max pooling 2D, and now size equal to 2. All right. So here we copy all these things. Then we paste. We have this now. So what we do is I remove this, and then this one what? Model 2. Okay. So since we do mass pooling, the mass pooling will reduce the size, okay, to 112. Then here it's going to change. So the size is not going to 112 again. I think I'll find a way to plot, to visualize some of these things. But 112, then 112. And here too must be what? 112. And here is what? 112. So after we apply the mass pooling, we should expect the size to come down, because so here become 56, right? 56 here to become 56. I think 112, yeah, 56. I'm making a mistake. This is not 121, 112. So 224, 224, 112, 112, 112, 112, 56. So here, I think we do the same thing, channel, in channel. So here it must be 2. Okay, you give them the name. Okay, here must be 2. Then we do the last one to it. Okay, which is also block 3. So here, remember, we are getting the layers. These are layers we're actually building. Okay, so here must be 3. Then coming here should be okay. So here must be filters rather, not the 3, because the filters that is returning. All right, the filters and filters and filters. Okay, and here should be 56. Here should be 56. All right, so here, if you do mass pooling, you should expect this one to come down to what? To 28, right? 28. 28. All right. So I think we are good to go now. Then we change here to be 3. Change here also to be 3. Change here also to be 3. All right. So I think we're good to go now. So okay. So I think the same pattern. We don't do anything. Same pattern, the same kernel size, channels, everything. Okay. Right. So what do we do? The next thing is you need to flatten. Now, remember, I did explain all these things. If you don't flatten it, the flatten that we need to be able to do our classification. Okay. So we need to flatten things out. Flatten things out. Okay. Flatten things out. So here we have model dot add what? Module, then what? Flatten. Then what? Flatten here. All right. So here we have this. Okay, so the next thing is for us to do our classification. So let's do our classification now. Classification, which is so our heading layer. All right, let's do our classification. All right, so we have the model dot, we add the same thing, add module, then I'll drop and drop out. So with the probability over here, we will help us. If P is greater than 0, else, okay, we replace with identify. That means the same thing. Yeah, if I'm not getting it wrong. All right, then module dot add module again and FC1. Okay, yeah. Linear, any feature. Okay. And filters, which is 28. I28. Wow. Our channel. No, don't have channel, no, our features rather. Is of 50. Then model dot add module value 2, then value. Okay. Then the last one is our output layer, which we have model dot add module drop 2. I'm not sure I can copy this. You have type in everything. Okay. P is equal to P. If P is always greater than what? 0. Okay. Else dot what? Identify. And here you have what? Model dot add module. You see 2. Linear. Any features. Go to 50 and out features equal to 4. Okay, so let me explain the Apple layer to you guys. All right, so here when we flatten it, we're going to do some form of calculations over here. So here at the end, we will get the size to be 20 by 20, but you need to multiply the size by the number of filters, because here we put in the in, which is 3. That's why you see 3 over here. But since we specify the filters ourselves, okay, the system is going to generate, which is called the random width or the initialized width. Okay, so the filters actually the feature maps. Let me use the word, the feature maps that is actually learning, the feature maps. Okay, so the feature maps is whatever we are returning. That's why you see that each in the beginning we have the filter. So here, when we get here, we'll end up getting the total number of filters and we'll plot it out. Okay, then when we look at our output over here becomes 4. Why is it 4? Because we have 2 classes. Sorry, we have 4 classes, not 2. We have 4 classes. So here we have the glioma, meningioma, pituitary. That's why I see it over here. 4. So if yours is 3, you must make sure it is 3. Now the values you are putting over here, for example, the out feature 50, whatever, it all depends on you. Okay, you can tweak them. Some of them goes all the way to 128, but remember computational resources. Okay, remember computational resources. So we don't want to waste computing power. Either way, we can do that. All right. So let's run it. If nothing goes wrong, we're able to see our model. So if I type our model here, because we already call it model, if I type our model here, I'm supposed to give me the architecture, okay, or maybe the summary. Let me do the summary. So it has just summarized everything for us over here. Okay, but this is something simple. When you take some of the pre-trained models, some of them, that's quite a lot. Okay, but this is something simple that we do. So let's set our hyperparameters and we start to train our model now. All right, so the next thing, first we set our hyperparameters. We set the hyperparameters. Okay, with the hyperparameters, what do we need? We need our loss function. Okay, so let's get our loss function coming. There must be 2. Let's get our loss function now. All right, so loss Fn is equal to n log cross entropy loss. Now we are using cross entropy because of what? Classification purpose. Okay. Then we will set optimizer with the Adam. All these things, I think I did explain them to you before. Okay, you can check your slides, right, and be able to. Okay, all right. So we put this one here. Then we're now going to train our model. Now, training our model, that is quite a lot, but I wish I could get certain things out quickly for us to be able to train our model. Okay, so there's a file I will share with you guys, because for me to be able to type all these things, that's quite a lot. So when I send the video, I will share the files also with you guys, where you are supposed to copy that file and put it in this cell. Okay, it's a full class, which I can't type everything. So I'll just paste it, copy it and paste it. But I will share this, I'll save it as Python file, which is this class. But you are supposed to copy it and put it when you get here and paste it over here, so that you don't need to type. But that's quite a lot, almost how many lines? 370 lines. That's quite a lot. All right, so let's get that one done, and boom. Okay, so if nothing goes wrong, we are going to train our model. Please, because this one is recording, I don't want to perform the training. Perform training of the model. I'm not going to set the epoch to a higher value. I'll set it to 5. But when you are doing your lab and also lab assignment, make sure you get a better value or a better model accuracy. Okay. The reason because I can't wait because it's going to waste my time, and I need to pause the recording and come back later, which I don't want to do. So I'll just set the epochs to 5, and we all wait optimizer. Well, with 5 is fine, but 5 I won't get a better result. But you can increase yours to maybe a bigger value, like 50. But remember, as you set it to a bigger value, it's going to take a lot of time. Okay, and you're going to use a lot of computing resources too as well. Okay, so valid loader. Okay, so once you're done, we now call our model trainer to train our model for us. Okay, so train the number of epochs. Well, epochs is equal to what? Number of what? Epochs. All right, so here, what do I even need? There's something I wanted to do prior. Let me skip them. Review. Let me do something. I want to tell you again something. All right, so when it comes, I'll show you. So here, I set this one to 5. Then I set my epochs to that. So I'm going to trim. So once, okay, so telling me group size, weight, blah, 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 channel instead of this. What is the issue? What is the issue? What is the issue? Making a mistake somewhere. Expected 32, but how did I put it? But I got 5 channel instead. Wow. So let me go through my script to be able to see where the mistake is coming from, because wrong click made a mistake somewhere. Oh, okay. So number of filters. So the number of filters was 5. And what again did I even set? Set it on the 3. And where is the mistake coming from? I'm coming in where with the error. Where? Where is the line? Where is this one? The trainer? It will be somewhere here. Okay, I'm just making a mistake. Then I'm making a mistake in the module. I didn't change certain things inside where. Let's go back and view it properly. All right, so here I have got 1 or 2, then Sorry, so here we have this, then come here. The mistake is all from here. And once you change all these things to filters, sorry, giving me 3. So here is our filters, and here too must be what filters, number of filters. All right, so these are the only places. Then what again? Yeah, I think that'll be all. Yeah, here must be filtered, here too must be filtered. The in channel, or they shouldn't be 3, have to be filtered. That's why I changed it. So I think that escaped me that. All right, so if you look at the max pooling, yeah, 5 will be, that's correct. So you run automatically again, you run this. As I said, this code, entire code, I'll send it to you. You don't need to type everything, I'll send it to you. So once you done run, let's run this, then let's see. It will take some time if you don't get any error. All right, but as I said, I'm running for 5 epochs, but you can run it to, there's something I wanted to show you. It has come now, so let it finish, or let me stop, let me cancel it. Okay, all right, so yes, when you come to settings, you come to accelerator, you use the CPU, right? I mean, if you are training models, visual models, like use the CPU to take some time. So you can use the GPU, either this one, okay, or that any of them. So this, when you turn it on, it is going to stop the session and start again. So when you are done with everything, then you can set it. When you're about to train, then you can set it to the GPU. So once you set it, you can go to run, and you run all. So let's run all from the top, then it will do that for us. So let's wait for it to complete. After that, we plot it, then we view our accuracy, and the rest is up to you for it to complete for. All right, so let's wait for it. It will finish right now. So maximum interactive session count of 1 will stop, 1 by other GPU other session to continue it. Okay, I think I'm still using all GPUs on my system, so let me use none here. And I can manage which can stop this. This one. All right, so it's good to go now. So it's running this. So let's wait for it to run. So we are going to see that it's going to plot the training loss and the validation loss. Okay, they are both supposed to fall. Okay, but you see, okay, you let it come. So let's hold on. It will finish right now because we are using the GPU. So the same thing, I'm also supposed to use the GPU. So let me pause the video. When it's done training, I'll resume the video again because the video is going to take memory. Where is my video? All right, so let's continue. So it's done training, but I ran into an error where when I chose the GPU P100, it didn't work. I ran into an error because I think I wasn't able to reach to the server. So I need to bring it back to this one again, which is the T4. All right, so once it's done training, I can plot, be able to visualize my stuff. So feed model trainer, then I can plot my losses. All right, so let's plot our losses to see. Right, so as I said, because this one I'm training it just for 5 epochs, but you see that the training loss is falling to 4, and the validation loss normally will rise. Okay, that is something we're supposed to learn, where you'll be able to find where you're supposed to stop. We call it some of these things. This stopping whatever, stopping potential, whatever. You stop your model when it's trying to rise again, especially the validation. Okay, but this is, I mean, it's not good. It's 0.5, which is bad. But should you increase the value to, let's say, 20 or let's say 30, it will come down. But remember, if you don't take it, it will overfit because the validation loss will increase again. Okay, and you need to stop it when the validation loss is trying to increase, or else your model will memorize or cache it. Okay, the training set. So don't use 5 for me. Increase yours to decrease that. Okay. So if I should get the accuracy, which you are going to do it right now. All right. You get the accuracy. You are going to see that it's not performing as usual. Okay. The accuracy is not performing as usual. So I pick my model trainer, which the code, as I said, I'll send to you. Then I pick then I pass the train loader to it. Then the model, I pass the model also trainer to it. Then I use the correct. Okay. So I can copy this and I run this. So here, let's see. It's going to run this and will print some statement for me. And also paste this one and change this one to the valid loader. Okay, the valid loader. Then I can also put one also here. Also change this one also to the test loader. All right. So is that the first one? So here, look at it. The first we saw. Let's come back here. So this is the training. Okay. So the training. So the first one is the glioma. Second one meningioma, and this and this. So here, what he's saying is that he had 930 out of this, 717 out of this, 936 out of this, and also 1072 out of this, which is for the trainer. Now let's see the validation. All right, so if you do the validation, let's see that one to what we had out of the total. So here you have 256 out of this, 258 out of this, 194, which is valid, 210, then I think this one is closer. Most of the time, I think it's able to get a pituitary more than the other ones. Okay, so let's see the testing. All right, so if you should do testing, you can even do prediction, but let's proceed. Okay, so let's look at it. So here, have you seen it? As you can see, the training, which is so bad, but I think it's more than half, so I can say it's okay. Because I use only 5 epochs. Okay, so when I did the training, did that, or if you look at it, for the testing, if you look at the testing, it was what, 400, 400, 400, 405, right? So the glioma, out of the 400, was able to predict 248 of them to be correct. The meningioma to 248, then the no tumor 328, then the pituitary 361. Okay, so I'll pause here, but you can go on to plot the graph. So you can go on to plot, come out with the confusion matrix. So you can come with the confusion matrix. So that's something that you should include. We should have the confusion matrix. Confusion matrix. You should include the confusion matrix. You should also include the receiver, which is the ROC, okay, curve. AUC curve. Okay, include that. Then maybe I don't know whether I should let you do some prediction, or if you even so we now see our validation loss, training loss. Maybe you can go ahead to plot the accuracy. You can even plot the accuracy. So once you do over here, you can plot the accuracy too as well. Okay. So plot the accuracy. Okay, for training, validation, and the testing. Now what you have there is the loss. It's not the accuracy. What you have there is the loss. This is the loss, not the accuracy. The accuracy is everything is calculated as 100%, so you can go on to do that. Okay. All right, so this is where I'll draw my curtains, so I'll close my curtains. All right, so I'm done with the tutorial. As I said, this file, I will send the file to you because it's quite a lot. It's a full class, so everything that is inside you can go through and be able to import some of them. Okay. All right, so That is that. So when I send this video, today's date is what? So you have up to 1 week, which is next week Friday, to submit the lab work and also the lab assignment. The lab assignment will follow. Okay, I'm going to send it right now, which I'll let you guys do maybe the same thing, but something a little bit different. Okay, all right. So thank you guys. Okay, if you have any challenge, you can contact the class rep. They will get in touch with me, and then I'll address that. Okay, so bye.